Hi, I'm Louis from Octopus Network. The whole idea of the Octopus Network built upon application-specific blockchain, AppChain for short. Compared with smart contract, AppChain is a decentralized application tech stack with significant advantages, most notably low usage cost and great customizability. The latter is particularly prominent when the application-specific blockchain is built on Substrate, which is the most powerful blockchain framework ever exist. Here I will introduce a unique design pattern of Substrate AppChain, application-specific Oracle, which can be reasonably used to open up new design space for Web3. The application-specific Oracle implementation rely on the Substrate opt-in worker. First, I will introduce how we use opt-in worker to achieve trustless cross-chain interoperability between AppChain and the near blockchain. Generally speaking, trustless cross-chain interoperability refers to light client verification, that is, chain B maintain a light client of chain A on its chain so that transactions or events from chain A can be independently verified without trusted third parties. In the design of Octopus Bridge, the cross-chain event propagation from AppChain to near perform in this way. Different blockchain and different cross-chain use cases require different design trade-off, which lead to different interoperability solution. There are no silver bullet for blockchain interoperability. For heterogeneous cross-chain, when blockchain on the two sides are not in the same type, unequal design could be applied to each direction. Near Rainbow Bridge and Octopus Bridge both work in this way. We call them asymmetrical bridges. Since the security of the Octopus app chain rely on fault proof, that is, when some validator colluded for malicious action, as long as there is one honest validator who can submit cryptographic evidence of malicious behavior to the Octopus relay running on the near blockchain, the attacker will pay a higher price than what they can get from attacks, therefore ensuring the app-chain security. So every validator needs to have a capacity to submit transactions to the near blockchain. Compared with require validator to run a separate challenge daemon, use off-chain worker is obviously a way that with low maintenance cost and much more manageable, since off-chain worker logic can be upgraded as a part of Substrate's runtime without a fork. Therefore, each validator node of Octopus AppChain will maintain an RPC connection with the full node from near blockchain that is trust. This connection will also enable validator node to independently observe the near blockchain. So the Octopus app chain can obtain cross-chain events from the near blockchain without participant of any off-chain process, relayers, or witnesses. After obtaining a cross-chain event, validator of the app chain will vote on the chain to reach an agreement on that happen. And the voting weight is equal to the staking amount. It can be seen that the app chain validator are acting as oracles. The scope of consensus participation and the voting weight are identical with the app chain itself. No third party is introduced and no extra cost assumption is added. So this is a trustless cross-chain design. A trustless and relayerless oracle is perfect way to perform cross-chain message transfer. It is very simple and elegant with high reliability and do not require additional off-chain process assistance. What's more, it's very fast. Cross-chain transaction can be confirmed within a few seconds. The best part is edge cost is nearly zero. Since there's no additional off-chain process and no need to pay the target chain transaction fee, while validator voting transaction can be configured for zero gas. Unfortunately, only the substrate blockchain have the ability to do that when it is the target chain. Well, Octopus AppChain use AppChain worker to implement an application-specific oracle for cross-blockchain interoperability. The purpose of application-specific oracle extends far beyond cross-chain. The core essence of any decentralized protocol or crypto network is to bootstrap and maintain internet platform economy with network effects by rewarding the contribution from different type of protocol participants with tokens without need for centralized organization such as companies. In order to maintain the permissionless and the censorship-resistant nature, crypto networks generally do not impose requirements on the identity of protocol participant. As a result, the core problem in establishing a crypto network become how to verify and quantify the contribution from anonymous participants on the blockchain and give token rewards according to predefined rules, which is part of the protocol. The ability to verify contribution on-chain determines the boundary of Web3. In other words, every time Web3 expands its territory, it's because developers create new way to verify contributions. For example, the Bitcoin network needs consensus on the order of transactions, but cannot rely on the trust from any particular entities. Therefore, it is necessary to find a way to randomly select a miner to produce the next block, and everyone else can verify the randomness is fine. Satoshi Nakamoto solved this problem with a proof of work design. The higher the computing power a miner provided to the network, the greater his contribution to the network security, and the greater possibility that obtaining block rewards. The same is true for proof of stake. The higher the total stake, the higher the cost of attacking the network. Therefore, it is reasonable for the network to allocate token rewards according to the amount of staking. Liquidity mining is the key driving force behind DeFi, which can be interpreted as proof of liquidity mining. In the above three examples, the contribution of the participants all happen on-chain, so it can be verified on-chain fairly easily. But in other type of network, the contribution of participants happen off-chain, and verifying this contribution on-chain is less straightforward. Fortunately, there are always some creators who can figure out ways to do that, thus expanding the boundary of Web3. For example, proof of coverage for Helium network, proof of space and time for Filecoin, proof of relay for Pocket network, etc. Among these genuine innovation, I especially appreciate Arwiv's proof of accessibility, which through clever design translate store data verification into a proof of accessibility that is much easier to generate and verify. While in the aforementioned network, the contribution of participants need not happen on-chain, they still have to happen inside the network. Therefore, network node can attach crypto evidence to the process or the result of the contribution. This evidence is then verified on-chain and become the basis for rewarding. But what if the participants' contribution happen outside the network? For example, is that possible to encourage participants to spread some idea on Twitter through a decentralized protocol and give token rewards based on the contribution of spreading? Twitter and other social networks are outside of crypto networks, and there is no verifiable crypto evidence of what happened on them. But both social network and the crypto network are in the same internet. Through application-specific Oracle, crypto network can actively observe events happen on social networks, reach consensus on them, and give corresponding token rewards. Let's imagine an example that is even more bound than social networking propaganda. Decentralized sports league. Venue owner organize sports events and sell tickets via crypto network in which athletes are registered. Game results are published on the website and obtained by crypto network through an application-specific oracle. According to the result of the game, athletes, judges, and events organizer will receive token rewards. Broadcasting rights and tickets are protocol revenue, which are distributed to token holders. Now you can find just as long as the activities of protocol participants left data on the internet, it can be actively observed by application-specific oracle and become the basis for token rewards. I hope everyone understand and use application-specific oracle as a powerful tool and become the next pioneer to expand the boundary of Web3. Thank you.